We will now have a look at angle of inclination. And before we start, just a reminder on how to do mathematics. So number and copy the examples. Ask your tutor or teacher if there are any steps that you do not understand. And number your questions. Unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Then mark your answers. If it is incorrect, write down the corrections and make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. So the overview of this video is first just quickly going to look at the formula. Then we're going to calculate the gradient when we're given the inclination of this line. Then we'll calculate the inclination when we're given the gradient of the line. And then we'll calculate the angle between two lines. Now the formula is as follows. Tan theta equals to gradient. So whenever I have a straight line that has a gradient, it will always have an angle between the x-axis and the line itself. That is the angle theta between the x-axis and the line itself. So whenever I have the gradient of the line, I can simply substitute it into this formula and I can solve for theta. Or if I'm given theta, I can then substitute it in here and calculate the gradient. Right, so let's look at how to calculate the gradient when we're given the inclination. So for example 19, determine the gradient of the following line. So we are simply going to use our formula where tan theta is equal to the gradient. So the gradient will then just be equal to tan, where I substitute in the angle. So that's going to be 56,31. And then I just use my calculator to calculate that value. So I say tan 56.31, and that is equal to 1,5. So that's equal to 1,5. Alright, so that's pretty straightforward. So question 19.1, determine the gradient of the following line. We know that tan theta is equal to the gradient, so my gradient is equal to tan with theta being 71,57 degrees. So substituting that in, we have tan 71.57, and that's equal to 3. Now for question 19.2, we have this angle. Now, once again, I just say tan theta is equal to gradient. So gradient is equal to tan of 111,8 degrees. And calculating that, we have tan 111.8. And that gives me negative 2,5. And then that's done. Now for calculating the inclination when we're given a gradient. So for example 20, determine the inclination of the straight line that passes through the points. Now in this case we're not directly given the gradient, but we do know if we have 2 points how to calculate the gradient from that, because the gradient is just the change of y over the change of x. So substituting in my values, I like to write them underneath each other. So this will then give me minus 2 minus 7 over 3 minus 8. And this gives me negative 9 over negative 5. And this is then 9 over 5. Alright, so now the formula I'm going to use is tan theta equals to the gradient. But now we know the gradient and we want theta. So in order to isolate theta, I'm going to take the inverse of tan on both sides. And that would then give me theta is equal to tan, the inverse of tan, the gradient of the inverse of tan. So now I just substitute in that value. So this is then going to be equal to tan the inverse, and 9 over 5 is my gradient. And then when I substitute that into the calculator, all I do is, you can see here's tan, and then the yellow part is the inverse of tan. So you're going to say shift tan, and then put in the gradient for that. So that's 9 over 5, and that's equal to 60,95 if I round that off to 2 decimal places. So 60,95 degrees. So for question 20.1, we need to determine the inclination of the straight line that passes through these 2 points. So very first thing, we need to calculate the gradient, y, the change of y over the change of x. So I substitute that in just to write them underneath each other, 4 and 7. So 5 minus 7 over -1 minus 4. And this gives me -2 over -5, which then becomes 2 over 5. Alright, so formula is tan theta equals to gradient, but I know the gradient, I want theta, so theta is the inverse of tan of the gradient, and then I substitute that in, so inverse of tan of 2 over 5, and then I simply calculate that. So we have shift tan, and our gradient is 2 over 5. So that gives me 21.8 degrees. Then for example 21, now the line y equals half x minus 2 is sketched below. Calculate the value of theta. Now here, the form, or how we're given the gradient, is we are given it in the form of a straight line, but we know this straight line is already in its standard form, and we know a straight line is y equals to mx plus c. Now here is our gradient. The coefficient of x is our gradient, so this then is my gradient. And once again, I just go to my formula, tan theta equals to gradient, and since I have my gradient, I want to solve for theta. Then theta is the inverse of tan of the gradient, and then I just substitute in my gradient. So this is then tan minus 1 tan, the inverse of tan over half, and calculating that, say shift tan, then 1 over 2, and that gives me 26,57, rounding off to 2 decimal places, so 26,57 degrees. Now the line 2 over 3x plus 4 is sketched below. Calculate the value of alpha. Now here we know that this is my gradient, so tan theta is equal to the gradient, and solving for theta, we have the inverse of tan of the gradient, so the inverse of tan of 2 over 3, and that gives us shift tan 2 over 3, and that's equal to 33,69 degrees. Then for example 22, it says the line y equals to -3x plus 1 is sketched below. Calculate the value of beta. Now here is a trick, because when you have a negative gradient, the line always slopes to the left. So when you're going to use your formula, tan theta equals to gradient, and you're going to substitute in a negative gradient. So we want theta, or in our case we want beta actually. So we want beta. So beta will then equal to tan inverse of gradient. Now when I substitute in a negative gradient, you're going to see that you're going to get a negative value for beta. So what you're going to get is you're actually not going to get beta, you're going to get this angle over here, and we can call that beta 1, right? Just for calculating that. And then after that you have to find the beta. You can either use angles on a straight line, but I'll show you a very simple way of doing that, because since this is a negative value, into the negative we just add 180, and that would actually just then give us the value of beta. Alright, so always remember, if I have a line like this, my theta in my formula is always that angle, but if I have a line that goes like this with a negative gradient, the angle in your formula is always going to be this angle over here. Alright, so let's substitute that in and then see what we get. So we know our gradient is negative 3. So tan minus 1, negative 3 of that, and putting that into the calculator, so shift tan of negative 3 gives me negative 71,57. So negative 71,57, and that's what I was referring to when you will get a negative value. So this negative 71 is this angle over here. Now the easiest way to get beta is just to simply say beta will be equal to beta 1 plus 180. It will always work out like that. So without even removing anything from your calculator, you just simply say plus 180, and that would give you your most accurate value actually. So this is then 108,43. So beta is 108,43, and always check that your angle, like you can see this is an obtuse angle, it's greater than 90. So if you get a value, if you actually said, okay, no, my answer is 71, but you see beta is bigger than 90, then you know something's not right. So always double check yourself with that fact. Is my angle an obtuse or is it an acute angle? So question 22.1. The line y equals to minus 1 over 4x minus 7 is sketched below. Calculate the value of theta. So once again, because this is our gradient, and our gradient is negative, we know we're going to get this angle. Theta, let's call it theta 1. Now, my formula, tan theta 1 equals to gradient. So theta 1 will be equal to the inverse of tan of the gradient. So we substitute in our gradient, tan minus 1, negative 1 over 4, and then to simply type that in, shift tan minus 1 of negative 1 over 4 is equal to negative 14,04. So negative 14,04 degrees. And now theta will be equal to theta 1 plus 180 degrees. So if I substitute that in, so that's minus 14,04 plus 180 degrees. And then all I do on my calculator is just say with my answer for theta 1, just say plus 180 degrees, and that would give me 165,96. So 165,96 degrees. Okay, now we know how to calculate both the gradient and the inclination. Now let's look at calculating angles between two lines. So for example, 23, calculate the value of theta. Now we see that we're given an indication that there's an angle and there's an angle as well. And we actually know now how to find these two angles. And then for the rest of the part, once we have found these two angles, let's call them alpha and beta. All right. Then after we found alpha and beta, we can then just use geometry in one way we can use exterior angle of a triangle to find to find theta, because we know that theta plus alpha will equal to beta. Or you can go a longer way and say angles on a straight line, and then you have these three angles that you can use angles of a triangle with. But we're definitely going to use exterior angle of a triangle, which is far shorter. So to start off with, the first thing I need to do is now to get the gradient. So this is quite a long sum actually. We need to get the gradient of BD. So change of y over change of x, so that's 2 minus negative 1. 2 minus negative 1 over 6 minus negative 3. Minus negative 3. And this then is 3 over 9. 3 over 9, which then becomes 1 over 3. All right? And then to find alpha, we just say tan of alpha will equal the gradient. So my alpha will then equal to the inverse of tan of 1 over 3, which is then equal to, so we have inverse of tan of 1 over 3, and that gives us 18,43. So 18,43 degrees. All right, so now we've got that one. Now for beta. Beta, we first need to find its gradient. So the gradient of CB is change of y, so 2 minus negative 2, 2 minus negative 2 over 6 minus 5. So that gives me 4 over 1, which is just 4. So gradient tan beta is equal to the gradient. So beta will be equal to the inverse of tan of the gradient. In our case, it's 4. And then we can just calculate that. Shift tan 4 is equal to 75,96. So 75,96 degrees. All right, now we have our two angles, and all that is left now is from exterior angles of a triangle. We know that theta, or let's start with we know that beta is equal to theta plus alpha, and that is exterior angle of triangle. All right, so now to solve for the unknown one, theta, we just take alpha to the other side. So theta will be equal to beta minus alpha. And then substituting in our values, we have 75,96 minus 18,43. And let's see what that equals. Is we have 75.96 minus 18,43. So this is then equal to 57,53. 57,53 degrees. Now calculate alpha. And once again, we have these two angles that we can find using the gradient of ED and the gradient of EF. And let's call these two angles, let's just call them X and Y. All right. So here we have to be careful, because this line actually has a negative slope. So we know when we're going to use our gradient formula, this is actually going to give us the angle of Y1, not Y. So let's just keep that in mind, but let's start with ED, finding X. And before we can find X, obviously, we need to find the gradient of ED, which is change of Y over change of X. So 4 minus negative 2 over 4 minus negative 1. And that gives us 6 over 5, because this becomes 4 plus 2, and that becomes 4 plus 1. All right, so the gradient or the value of x, if we have tan x equals to the gradient, then x is equal to the inverse, tan the inverse of the gradient, which we just found as 6/5. And then that gives us, so you say shift tan 6/5, and that is equal to 50,19 degrees. Okay, done for that one. Now let's move on to the gradient of EF. The gradient of EF is equal to change of y over change of x, so 4 minus -2 over 4 minus 7. So this is then 6/-3, and that gives us a gradient of -2. Okay, so tan of, and remember, because we have a negative gradient, I'm going to find, or the value that we're going to get is a negative angle, which is this y1. So tan of y1 will be equal to the gradient. So y1 is equal to the inverse of tan of -2. And that will give us, so shift tan -2. So that's equal to 63,43. 63,43 degrees. So that should have been, yes, that was -63,43. And then to find y will be equal to my y1 plus 180. So this is equal to -63,43 plus 180, which is then equal to, so if I just say plus 180 on my calculator, I get 116,57. 116,57 degrees. Okay, and now we have x, we have y, and once again we can use exterior angle of a triangle, because y will be equal to x plus alpha, exterior angle of triangle. So substituting in or solving for my unknown alpha, I take my x over to the other side and get y minus x. So alpha is then equal to y minus x, and if we substitute in those values, y is 116,57 minus the 50,19, and this will give us 116,57 minus 50.19 is 66,38. Then for question 22.2, calculate the value of beta. Right, now this one is another tricky one, because if we find this angle over here and this angle over here, this wouldn't actually give us, this is not like an exterior angle of a triangle. This would be extremely hard to actually get to beta from those two angles. So what we're going to do is we are going to construct a line over here. I actually want to show you something in the previous example. If we had, there's another way you can actually solve for alpha in this one even, and that is to construct a horizontal line that runs parallel to the x-axis. And then if you extend these two lines, this should give you the x, and this one, this angle, this big angle over here, would give you y. So another way to find alpha over here, see this is vertically opposite angles which are equal, is to actually construct your horizontal line, and then these corresponding angles is x, and these corresponding angles this one will then equal to y because of corresponding angles, because these two lines we construct them to be parallel. And then to find this angle, you take your big angle and take away the small angle. That would leave you with alpha, and then just vertically opposite. But obviously, in this case, this is a lot more calculations than just using exterior angles of triangles. But now when we are over here, this one would be best to use that method. So if this line runs parallel to the x-axis, then this angle over here, so this would then just be the angle, let's call that one x in this case. So this would be the angle for line YZ, if I use that in my formula. And this line over here, this big angle over here, would be the angle that I would get if I use the gradient for line XY, and let's call that one angle Y. All right, but because this angle is has a negative gradient, also just remember that we are going to get Y1 first before we can get Y, because of the negative gradient over here. Okay, so now we got a few things to do. First, let's find x, and before we can find x, we need to find the gradient of YZ, which is change of y, so that's -2 minus -4 over change of x, 3 minus -3, and that gives us a -2 plus 4 gives me 2 over 6, which is just 1 over 3. All right, now for x's value, we get tan of x is equal to the gradient. So x is then the inverse of tan of 1 over 3. So we have shift tan 1 over 3. And that's equal to 18,43 degrees. Okay, now that done. Now moving on to the gradient of xy. So gradient of xy is change of y, so that's 2 minus -4 over -4 minus -3. And this becomes 6 over, and this one is -1. So this is then -6. And then to find y, so tan of y1 will be equal to the gradient. So look at this. This is the gradient. This was the gradient of this straight line over here. And we are going to get, if we substitute in the, y1 actually goes up to here. Yeah, y1 goes up to, no, y1 is just over here. Okay, so that means then that the gradient, or y1, is equal to tan minus 1 of 6, or -6. So shift tan -6. And that gives me -80,54 degrees. Okay, so in order to get y, we need to say y is equal to y1 plus 180. So this is going to be -80,54 plus 180 degrees. And just as it is here, I'm just going to say plus 180. And this gives me 99,46. Okay, right. So in this case, we have now found y1. We found y, we found x. And now if you look at beta, beta will just be equal to my big angle, take away my small angle, then beta will be left. So we have y minus x, so substituting that in, y was equal to 99,46 minus the small value x, which is 18,43 degrees. So that is equal to 99.46 minus 18.43. And that's equal to 81,03. All right, then we're done.